Hello, Cougar Academy Algebra 2B, and welcome to lesson 5.4. Today we are getting into the quadratic formula. So our essential question, how do you solve quadratic equations using the quadratic formula? We've seen a few different ways. Today's is kind of the foolproof way, works for every type of quadratic. And just a reminder that quadratics, okay, what I mean when I mention quadratic equations, those are in the form ax squared plus bx plus c. Anything to the squared power with those coefficients is known as a quadratic, okay? Now, the main thing for today is this quadratic formula. And over time, and many years ago, this was developed by some very bright mathematicians. And the quadratic formula is x equals, get ready, negative b plus or minus the square root, oh my, of b squared minus 4a times c all over 2a. What? Okay, I promise it's really not bad. You're just going to be plugging things in and solving. The people that had to come up with this formula, they had the tough job. So please write that down. Try and memorize it. It's really not too bad. There's little jingles and songs online. But anyway, negative b plus or minus b squared minus 4ac all over 2a. Graphing calculators will also be helpful for you here. Okay, a few things to note. Our quadratics, in order for this to work, must be set equal to 0. Okay, they must be set equal to 0. If they're not, you're just going to move by adding or subtracting whatever is on the right side to make it 0. Okay, so our first example, solve each equation with the quadratic formula. Just remember, so a, b, c are a, b's, and c's. A is the number in front of x squared, so it's 6. B is the number in front of x, and c is the number all by itself. And really, we're just going to substitute everything in to the good old formula. Okay, so negative b is negative 3. This is b, this is a, this is c. Plus or minus the square root of b squared, so 3 squared minus 4 times a times c. Okay, c is negative 9 with that there. All over 2 times a. I recommend writing this part down. And the next important thing is I want you to do all of this in the calculator, okay? So notice how I'm going to type this in. We call that part the discriminant, okay? Discriminant. Nothing too important for us here, but please do everything in this square root first, because that's where a lot of little mistakes are made. So I'm going to have negative 3 plus or minus the square root, and watch in my calculator how I'm going to type this in. Parentheses, 3 squared minus 4 times 6 times negative 9. Exactly. And I get 225. Okay, so I do that before I take the square root. And that's all over 12. Different things will happen. We'll see some different examples. The square root of 25, since this is a perfect square, you can try and take that. Square root of 225 is 15. So really what we have is negative 3 plus or minus 15 all over 12. And that's what x equals. And since that's nice and comes out to be a perfect square root, we have two problems essentially we can set up, and that's x equals negative 3 plus 15 over 12, or x equals negative 3 minus 15 over 12. We have two different options. One of them's the plus, and one of them's the minus. Okay, again, just little things to be careful of. If you type these in your calculators, make sure you do the numerator first. Simple order of operations stuff. So it's negative 3 plus 15 divided by 12, which is 1. So x equals 1. And negative 3 minus 15. And negative 18 divided by 12. And you'll get a fraction. Negative 3 halves. Okay, so that's really it. Okay, the formula might be scary at first, but you're just typing stuff in and just being careful with this discriminant typing it into your calculator. Okay, so let's check out some other examples. Right across is 2. Now I mentioned we have to set it equal to 0, so we're going to subtract 5, and it's going to come from the c value because there's no x or n in this case. So we have 3n squared minus n, negative 9 minus 5, negative 14 equals 0. At this point, we're happy, we can use the quadratic. So, negative b, now it's negative of the negative 1, so it's positive 1. Okay, opposite of a negative is positive. You can write it out, or you can skip that step, it doesn't really matter. Negative 1 squared, notice the parentheses, minus 4 times a times c all over 2a. Okay, opposite of negative is positive, and again I would recommend just typing exactly what that discriminant is right into the calculator, parentheses and all, and we get 169. Okay, 169 all over 6. Okay, if you can, try and take the square root of 169. If you already know, that's going to be 13. So here we have 1 plus or minus 13 all over 6. Let me fix that. I almost drew a square root. Okay, so x equals, and since that's nice, we can split it up into 2 problems. 1 plus 13 over 6, 1 minus 13 over 6. So 14 over 6, which is a fraction of 7/3. Boop, boop. Or 1 minus 13, negative 12 over 6, or negative 2. Okay? You should always get 2 answers in some shape or form. Okay, I'll emphasize that a little bit later. And that's it. Make sure you're set equal to 0. Okay? Last one. So now we have all these things, and we want to set it equal to 0. Typically, sorry to interrupt. Yes, I am enjoying this. You are interrupting. Okay? Typically, you want, I mean, it doesn't matter, but you should keep the n squared positive. Okay, so I'm going to add over the 21 and the 10n, and subtract the 10n. Now be careful. This is our b value. This is our c value. So I have n squared, okay, minus 10n and plus 21 equals 0. So it's helpful to have it in this order. Okay, from here, negative b. So I'm just going to put 10 because it's opposite of negative, plus or minus, square root. If you're getting kind of quick with these, b squared is going to be 100 minus 4 times a times c. A has a 1 in front of it, so it's just 1. All over 2 times 1, or just 2. So you could start to take little shortcuts like this. This number is always going to be positive. I highlighted it in blue. It should always be positive because you're squaring a negative. And again, in the square root there, I have 100 minus 4 times 21 times 1 technically, and that comes out to be 16. So 10 plus or minus root of 16 all over 2. I got 2 old problems here. Okay, root of 16 is really 4, so 10 plus 4 all over 2, 10 minus 4 over 2, and 14 over 2 is 7. And 6 over 2 is 3. Okay, so start to take those little shortcuts if you can. We're going to look at some different types here. Those all came out to be regular numbers. There are examples. These next ones are irrational numbers. Okay, you're going to do the same process, only they're going to look a little different at the end. Okay, so again, let's get it equal to 0. Add 21. So I have x squared plus 11x plus 21 equals 0. We're going to quadratic form this guy. So negative 11 plus or minus square root b squared. So 121 minus 4 times a times c all over 2. because it's just 2 times 1. And let's see what we get. Negative 11, 121 minus 4 times 21 is 37. Okay, I typed that in okay. Negative 4 times 21, yes. Plus or minus root of 37 all over 2. And at this point, so these are irrational examples because the square root of 37 is not a perfect square. Okay, so it cannot be broken down. It's unbreakable. And you also can't simplify it. We could try any perfect squares that go into this, but there are none. So that is actually just our answer, is negative 11 plus or minus root of 37 over 2. So if they come out to be a non-perfect square, you could just leave this as an answer, and it makes it much easier. Okay, if you can break down the 37, try to, and I think our next example, I'll show you that. Okay, so irrational examples. 5x squared equals 4. What? Okay, well, let's again just set it equal to 0. So minus 4 equals 0. A few things to note here. Okay, a is 5. B, there is no x term, okay, so it's 0, and C is negative 4, okay, because there's no x to the first power. Okay, you can still use the quadratic though. Okay, we just have 0 plus or minus square root of 0 minus 4 times 5 times negative 4 all over 2 times 5. Okay, it's going to look a little funky at first, but it's okay. So 0 plus or minus is really just plus or minus. Let's do 0 minus 4 times 5 times negative 4. That's going to come out to be 80 all over 10. Okay, and here's where you want to now work on your other things, like breaking up square roots. So square root of 80, if you remember, we can break up, I believe 16. Does 16 go into 80? Yes, it does. It's the square root of 16 times square root of 5 all over 10, plus or minus, which equals plus or minus 4 roots of 5 over 10. And in this case, so notice how 4 and 10, they each have common factors. You could simplify this as, so 4 divided by 10 can each be divisible by 2, plus or minus 2 roots of 5 all over 5. Okay, so that's an example there with a few different things. B value of 0, and also break up square roots if you can. All right. The last type of problem involves complex number examples. So we saw regular numbers, irrational, now complex, which remember, those are our imaginaries. Okay, and they're really not bad. Set equal to 0, 12n squared. I'm going to subtract 8n and add 12 equals 0. And we can quadratic form this. So negative b, 8, plus or minus square root. 8 squared, 64, minus 4 times a times c all over 2 times a. And there we have it. Now let's see what happens. So this becomes 8 plus or minus square root 64 minus 4 times 12 times another 12. Oh man. Did I write that down right? Yes, I did. And negative 512. What? Okay, all over 24. Okay, so we got more things going on here. Square root of 512. 1, it's negative. That means I is involved. So really this is 8 plus or minus I roots of 512 all over 24. Next, let's think of 512 and what perfect squares go into that. Or maybe it is a perfect square. Is 512 a perfect square? Look at that, no it's not. So we're going to go to the table. We're going to see what the biggest perfect square. See, 4 does, I'm guessing, a bigger one. 64 and 8. 16 squared. What is 16 squared? My goodness, 256. Look at that. Okay, so after all that, 8 plus or minus I roots of 256 times 2 all over 24. And if you don't know all those, that's okay. Really then, so 8 plus or minus 16 I roots of 2 all over 24. And at this point, so 8, 16, and 24, they can each be divisible by 8, actually. So we have 1 plus or minus 2I roots of 2 all over 3. Wow. Okay. So, big number here, square roots. Type in your calculator. I know I even had trouble finding that one. But just take your time and look through and try and get the biggest one out that you can. Okay? But that's how you'd leave your answer. There's just an imaginary thrown in there. So be careful with those. Last example here. Okay? Set equal to 0. See if you can even get most of this on your own. So 12n squared plus 7n plus 10 equals 0. Did you do that first? If so, great. Quadratic formula, -7 plus or minus square root 7 squared, 49 minus 4 times a times c all over 24. If you have something similar to that, fantastic. Pat yourself on the back. Take care of that discriminant. 49 minus 4 times 12 times 10. -431. All over 24. Okay. Take care of the I roots of 431 all over 24. And this is fantastic. If you're at this point, be proud of yourself. 431, that's an ugly number as far as square roots are concerned. Not really a clue as to what perfect squares go into it. Boom. Okay. Hey, we're going to leave it like that. And yes, that will be our final answer. Okay. So you can leave it like that and just make sure you take care of the negative bunch there. Bring that out. And if you do get a funky square root, do like I did. Take your time, look through to see if there were any perfect squares. Did I miss one? If I did, send me a note in the comments or something like that. But I think I tried to see them all. Okay. So nice job on those. They'll take a little bit of time. But again, just do your best. And nice job, guys. Thanks.